Hey, what's going on, guys? Today we're going to be looking over area of rectangular figures. So right here it gives us all the equations for the area of rectangular figures. You don't need to worry about memorizing these formulas. What's more important is being able to identify which shape is what, and for example, what B and H stand for, and what D1, D2 stand for, so on and so forth. So let's go ahead and look at some examples. So on number one, we have a kite, okay, and it gives us one diagonal, which if we look at the area of a kite slash rhombus, it's diagonal 1 times diagonal 2 divided by 2. So they give us one diagonal right here, all right, 12 and 8. So one diagonal is 12 plus 8, which is 20. So then we need to get this diagonal. Obviously, they do not give me that diagonal. So I need to find a piece of it. So what I can do is isolate one of these triangles here, because a kite is basically like four right triangles kind of put together. So I can isolate and look at one of these right triangles right here, where I have a hypotenuse of 13, a leg of 12, and I need to find the other leg, call it x. So I have a right triangle, I know two sides, and I'm trying to find the other side. So I use Pythagoras' theorem. So I have 12 squared plus x squared equals 13 squared. So x equals the square root of 13 squared minus 12 squared. This goes to the square root of 25, which is 5. So x right here is 5, and that means this side right here is 5. So our total length for diagonal 2 is 10. So that means the area is diagonal 1, 20, times diagonal 2, 10, over 2. That's 200 divided by 2. That goes to 100 units squared. We don't have units written here, so you can just use a U for units. Let's go on to number 4. So we have a trapezoid. Number 4 is a trapezoid. And if you look at the area for a trapezoid, it's base 1 plus base 2 times height divided by 2. We have base 1 here, base 2 here, height here. So the area is just 15 plus 4 times 8 over 2. Okay, so if you put that in your calculator, you end up with 76. And since we have units, we'll say inches squared. For area, you'll always square your units, because essentially it's saying that it's a two-dimensional thing, which area is a two-dimensional thing. So later when we go over volume, your units would be cubed, because volume is a three-dimensional measurement. Moving on to example 6. So it gives me a parallelogram. So I know that the area for a parallelogram from above is just base times height. Okay, and I have my base is 26, but I need my height. And clearly, as you could probably deduce from the fact that we restate your special triangle rules directly above, we're going to have to use special triangles to find our height. So if we look to the very left of our parallelogram, we have a 45, 45, 90 degree triangle. Okay, they give us the side directly across from 90 degrees as 22, which we know is s times root 2. So in order to get this side, it's s. So 22 equals s root 2. So I divide my root 2 over. Okay, now this is technically correct, but don't forget that's because old Greek guys did not have calculators that we rationalize when we have something like this. So this is correct, it's just kind of ugly. So we'll make it look prettier by multiplying the top and bottom by root 2. 22 times root 2 is just 22 root 2. Root 2 times root 2 is 2. 22 divided by 2 is 11. So this is all 11 root 2. Now, that's the full math. The trick really is just to do this faster, which it is kind of a trick because you don't really write anything down, but if you're given a 45, 45, 90 degree triangle, and the side they give you is the hypotenuse, okay, you can essentially just divide that by 2 and attach a root 2, and that will give you your answer for S. So 22 divided by 2 is 11, and then we just attach a root 2, 11 root 2. So all that work to get my height, and that is my height. So now I can just say that my area is 26 times 11 root 2. Okay, multiply the 26 and 11 together, that goes to 286, and just attach that root 2. And this would be inches squared. Moving on, we'll take a look at example 8. So on example 8, you have a trapezoid, okay, and you have your base 1 here, base 2 here, but I need to get my height. Okay, and again, as you could probably deduce, you're going to have to use trig, considering we restated our trig rules for you. Okay, so I have 35 degrees right here. Relative to 35 degrees, the height, which is what I'm looking for, is the opposite. But I don't have another side on this triangle. So I need to find a way to find one. There's 90 degrees here and 90 degrees here. That's going to imply that this side and this side are the same length. So that means this guy is also 7. Now, since this whole thing's 13, that means this side right here is 6. 13 minus 7. Okay? So, relative to 35 degrees, 6 is an adjacent side. So which trig function deals with opposite and adjacent? It would be tangent. So tangent 35 degrees equals O, opposite, which is my height in this case, over my adjacent. My adjacent is 6. Multiply the 6 over, so my height is 6 times tangent of 35 degrees. Don't forget, you will have to plug that into a calculator, tan of 35 degrees. There's not a way to calculate it by hand at this given moment. And if you do this calculation, this is about 4.2. So my height's about 4.2. So my area, which is base 1 plus base 2, so 13 plus 7, times my height, which is 4.2, all divided by 2. So this goes to 20 times 4.2, all divided by 2, which is the same thing as 10 times 4.2, which is 42 units squared. Okay, thank you guys. That's it.